In this section, our goal is to be able to solve multi-step linear inequalities algebraically and graphically. Let's look at some examples. Solve and graph the inequalities. Reminder, when you multiply or divide both sides of an inequality by a negative, you must change the direction of the inequality. Number 1, 5x plus 2 is greater than 3x plus 10. Remember, this is like an equation where we can draw a line where the inequality symbol is. The first thing we want to do is get our x's together on the same side. I see fewer x's over here, so using my subtraction property of inequality, I'm going to subtract 3x from both sides. 5x minus 3x makes 2x. I have 2 left, and on the other side, just 10 is left. Let's continue to put our greater than symbol on the line. Now I'm trying to get my x by itself. Let's remember our order of operations, just like with equations. We start with add and subtract and work our way up. So next to x is multiply, added to x is what we want to deal with first. So I'm going to subtract 2 from both sides, and I have 2x is greater than 10 minus 2, 8. And now I'm going to see that I'm multiplying 2 to x, so I will divide both sides using the division property of inequalities, dividing both sides by 2, and x is greater than 4. Notice it wasn't a negative that we divided by, so I keep the inequality going in the same direction. This is a good way to write our answer, but let me introduce you to set notation. We did this when we studied domain and range. We can also write our answer with the squiggly bracket and say x such that x is greater than 4. 2 ways to write our answer, just like this or in set notation. So because I have 4, I'm going to put 4 on my number line, some numbers above, 5, 6, 7, some numbers below, 3, 2, 1. I don't have an equal to line, so that means I just have a hole at 4, an open circle, and then it's greater than, so everything bigger than 4. And our trick to know which way, the arrow is pointing to the right. So not equal to 4, just greater than 4. Number 2. Negative 3 minus 6 times the quantity 4x plus 6 is greater than or equal to negative 111. We can start by distributing negative 6 to get rid of these parentheses. Let's draw a line at the inequality symbol like we do when it's an equal sign for an equation. Negative 3, negative 6 times 4x is negative 24x. Negative 6 times positive 6, negative 36, greater than or equal to negative 111. Now we can combine like terms. I see I have negative 3 and negative 36. Negative 3 and negative 36 make negative 39 when I combine those like terms. In front of that, I can put negative 24x. I have my greater than or equal to symbol. Notice I haven't moved anything to the other side yet. But now I'm trying to get x by itself, and I want to move all the other numbers to the other side. So the inverse of subtracting, adding 39 to both sides. That leaves us with negative 24x greater than or equal to negative 72. And now I have to get the x not multiplied to negative 24. The inverse of multiply is divide. So divide both sides by negative 24. And x is by itself. And on this side, I get 3. Now notice, we divided by a negative number. Look at that reminder when you multiply or divide both sides by a negative. And that's what we have here. We're multiplying or dividing both sides by a negative. We reverse this inequality. So x is less than or equal to 3. Let's practice our set notation for how to write this solution. X such that x is less than or equal to 3, squiggly brackets. 3 we can put on our number line with numbers bigger, 4, 5, 6, and numbers smaller, 2, 1, 0. Because we have the or equal to, we can fill in the point and less than points that way. All the numbers less than 3. Number 3. Negative 6 times the quantity 1 plus 7k plus 7 times the quantity 1 plus 6k is less than or equal to negative 2. Similarly to how we did the other one, we can distribute this negative 6 and we can distribute this positive 7 first. Negative 6 times 1 is negative 6. Negative 6 times 7k, negative 42k. Plus 7 times 1 is 7. And 7 times 6k is positive 42k. Less than or equal to negative 2. Now we can combine like terms. These constants are like each other. Negative 6 and positive 7, when I combine them, make 1. And these k's are like each other. Negative 42k and positive 42k make no k's. That's using the inverse property of addition. The k's are all gone. And then I have less than or equal to negative 2. So on the left side, I have 1 less than or equal to negative 2. Well, I have no variable left. I just have numbers. Let's think about this. 1, is it less than negative 2? I know it's not equal. Well, if we put negative 2 on a number line, negative 1, 0, 1, 2, 1, and negative 2. Here's 1, and here's negative 2. 1 is bigger than negative 2. It's greater than, not less than. This is not true. If it's not true, then we have no solution to this inequality. Another way to show this is with the empty set. We call this the empty set. Squiggly brackets with nothing inside. And on my number line, I don't show anything. No lines on my number line. Let's try number 4. Draw our line, and let's begin by distributing the negative 2 to the quantity 5 plus 6n and the 6 to the quantity 8 minus 2n. Negative 2 times 5 is negative 10. Negative 2 times 6n, negative 12n. 6 times 8 is 48. And 6 times negative 2n is negative 12n. We'll put our less than symbol in the middle. I don't have like terms to combine on this side or like terms to combine on this side, so let's begin by getting our n's together. Negative 12n and negative 12n on both sides, the inverse of subtracting is adding. But notice that there are the inverses on both sides, so the n's are gone altogether. No n's over here, just negative 10. No n's over here, just 48. Now this time, negative 10 less than 48, this statement is a true statement. Negative 10 is less than 48. So if the variable is gone and we end up with a true statement with numbers, then our answer is all real numbers. Remember, we had that with equations. Another way to show that is with the squiggly bracket. X, well, actually, n in this case, because our variable is n, so we will say n such that n is an element in R. the all real number set. And when we graph it on our number line, it's the entire number line. No starting or stopping points at anywhere. It's all of the points. Any solution, any number you pick will be a solution to that inequality. Number 5, select all values of x that satisfy this inequality. 7x minus 2 is less than 3x plus 6. So we could, one at a time, plug these numbers in and see if it's true. Satisfy means makes the inequality true. This is one of our key words that we want to make sure we notice in this unit. We're going to see it quite frequently. So we could plug each of these solutions in and see if they satisfy, or we could solve this inequality. Solving it is faster, so let's do that. I'm going to subtract 3x from both sides. 7x minus 3x is 4x. And now I want subtracting 2 to not be there, so the inverse is adding 2. Addition property says added on both sides. So 4x is less than 8. And then finally, the inverse of multiply is divide. So x is less than 2. So if we think about the solutions, they are any numbers less than 2. Is 5 less than 2? No, 5 is bigger. Is 2.1 less than 2? Nope, 2.1 is bigger. Is 2 less than 2? No, 2 is equal to 2. So that's not a solution. 0 is less than 2, so this one works. And negative 3 is less than 2, so this one works. 2.1 was greater than 2, and 5 is greater than 2, which is why these don't work. Take a couple minutes to write yourself a short summary. Describe the difference in using the words at most and at least. See you in class.